Hi, this is Paul from Miras, and in this video I'm going to show how to add background voltage distortion and line voltage imbalance to a harmonic simulation. Here we see the line diagram from SOLV, which we added in the introductory video, and we've added two VFDs with input harmonic filters on the power system. We've run the simulation and we've got 1.3% voltage distortion and 3.3% current distortion at the point of common coupling 1. Now we can add background voltage distortion to this model and see the results. You'll want to do this. This is a good idea when we haven't modeled all the loads in this specific facility. You can add the additive voltage distortion that you will have from other loads. You may also have incoming background voltage distortion into the facility from other users on the power system. And how we add this is at the left side of our diagram we have the source icon, and when we click here, this source data pulls up and we can add background voltage source distortion here in the middle, and we can add line voltage imbalance at the bottom. In this example, I'm just going to show how to use it. It's used by these slider bars. So for example, if we wanted to add 3% voltage distortion here, we would adjust this slider bar. We'll start with the 5th harmonic. We can adjust 5th, 7th, 11th, 13th, and 17th harmonics, which are the predominant low order harmonics that you'll see on power systems these days. We've added some 5th. We're going to add some 7th, 11th. We're going to taper it off until we get 3%. If we go over, we're just going to scale back a little bit and then add a little bit to the 17th. It's convenient to adjust the lower order 5th and 7th first. They have a stronger effect on the total VTHD because this is a root sum squared of this power system. So 5th harmonic is going to have a large effect on our 60 Hertz system frequency. So we've got 3% voltage source distortion here added, and I'm just going to add 1% line voltage imbalance. You can select from 0 to 5% line voltage imbalance. So we're going to click OK, and this adds here, we see on the one line, 3% and 1%. Now when we run the simulation, we can take a look at the results. Now we've got 3.4% VTHD, 3.4% ITHD. We can look at the wave spectrums. When we do that, we see all three phases. Now that we've added the imbalance, we show all three phases, and you can see the RMS values of both. And we've increased and you can see at the point of common coupling the voltage, the total VTHD is increased quite a bit. Now it's additive, it's vectorial, so the SOLV will calculate the total VTHD at your PCC1 and your ITHD at PCC1. Now when we run the report, we can check IEEE compliance. For example, this is now it's still showing pass across the board with the input harmonic filters. We can also generate a full PDF simulation summary report if we like here. And that's how you add voltage source distortion. So if you have any questions about adding it, or you need to talk to us as to how the best way to do it on your system, feel free to reach out to us and we'll be happy to help. Thank you.